So here we have a wind turbine, and we're given a formula that works out the height of the tip of blade A as it rotates. So x is the number of degrees that it rotates. It starts out at 0 degrees up here at the top, goes round 90 degrees, 180 degrees, 270 degrees to 360 degrees. And this formula gives us the height of the tip of that blade above ground level. So first of all, before we do the question, let's get a feel for this formula. This is not essential to solve the question, but it would be nice to get a feel for what the graph of this formula looks like, and we'll try and make sense of it. So what we're looking at just now is the graph of the cosine of x. It starts out at 1, goes down to 0, to -1, back up to 0, and then back up to 1. So as x moves from 0 to 360, the values of the cosine of x go from 1 down to -1 and back up to 1, ranging all the way from -1 down up to 1 again. The number at the front, let's increase that. Instead of 1 times cos x, there's 2 cos x, 3. We're multiplying the heights by the number that goes at the front. If you look at the question, you notice there's 23 times cosine. So there it is, it's 23. Instead of starting out at 1, it starts up at the height of 23, goes down to 0, and then disappears underground, because in this case we've got the wind turbine not on a mast. It's sitting at ground level. So it would start out at 23 meters high, the blade, and go down to ground level and then disappear underground. So let's put it up on top of the mast, and it's 40. So there we go, we're adding numbers to these values, and eventually we've added 40. So the blade now starts away up here at 63 meters above the ground. After a rotation of 90 degrees, it's down at 40 meters, then it goes away down to about 17 meters, then it comes back up to 40 meters, and then away up. After 360 degrees, complete turn, it's back up to its highest position. And notice that after 180 degrees, the height is the lowest it gets. It's closest to the ground after 180 degrees. So that maybe gives us a clearer understanding of what this formula means. So let's start work on solving this problem. First part, calculate the height of the tip of the blade A after it is turned through an angle of 60 degrees. So x is 60. The height, we're told, is 40 plus 23 times cos x. So that'll be 40 plus 23 times the cosine of 60 degrees. Let's figure out what that comes to. 40 plus 23 times the cosine of, now at this stage make sure that you're in degree mode. You want a deg or a d showing in the display, otherwise you'll get the wrong answer. So cosine of 60, that comes to 51.5. So at height above the ground, 51.5 meters. Let's move on to part B. And this says find the minimum height of the tip of the blade A above the ground. Now you remember the graph I showed you. Blade A is up here, 90 degrees, 180 degrees it'll be closest to the ground. So closest to the ground, minimum height, when x equals 180. It's rotated halfway around 180 degrees. And in that case, now cosine of 80 is 180 is minus 1, so it'll be 40 times plus 23 times minus 1. That's like 40 minus 23. So it would be 17 meters. If you're not sure of that, you would work that out on the calculator. So we'll do that again. 40 plus 23 times the cosine, checking your mode as degree, cosine of 180 degrees. And that comes to 17. Final part of this question, calculate the values of x for which the tip of the blade A is 61 meters above the ground. Now there will be two places that it's 61 meters above the ground. And that would be maybe here, maybe here. I think this is about 40. That comes to about 63 as the maximum. So 61 meters would be up here somewhere. So it would be, you'd expect it some angle less than 90 and then all the way around at some angle nearly 360 degrees. That's just roughly figuring it out. So let's have a look. When is the height, which is 40 plus 23 times cos x, when is that height equal to 61? Let's take away 40 from both sides. Take away 40 from this side, 40 from this side. We'll get 23 times cos x is equal to 21. Let's now divide both sides by 23. Remember, always balance both sides of equations when you're trying to solve them. So that'll get rid of that 23, and we'll be left with cosine of an angle is 21 divided by 23. Now, you remember the cosine graph starts out at 1, goes down to 0, goes to -1, back up to 0, back up to 1. There's 90, 180, 270, 360. So we're talking about a number that's nearly at 1. And that'll happen again here and here. We're in the first quadrant and the fourth quadrant. First quadrant, remember, it's an angle between 0 and 90. Fourth quadrant's an angle between 270 and 360. So the first quadrant angle that's between 0 up to 90, remember. So we'll look at the calculator and decide what angle. That's cos to the -1 on some calculators. In this one it's a cos. So what angle has a cosine of 21 divided by 23? That's the question I'm asking it. So cos to the -1, or second function cosine, and then put in 21 23rds. And there it is. The angle in the first quadrant is 24.07 degrees, or approximately 24 degrees. That's to the nearest degree. Now that's what we suggested would happen when we look at the picture. We suggested that it would be a small angle, less than 90, and that's 24 degrees that it's turned. Now by symmetry, I suppose we could say it's 360 minus 24 looking at this picture. But let's do it another way. So the fourth quadrant angle, and that's 270 to 360. Some of you might have learnt a diagram like this where you're looking at first quadrant, then fourth quadrant all the way round to 360, and then you subtract the first quadrant angle. So you'd subtract 24 from 360, which is what this diagram about the blade is suggesting. So the fourth quadrant angle is x equals 360 minus 24 degrees. So that's 336 degrees. So we have our two angles. If the blade rotates 24 degrees, the tip of the blade will be 61 meters above the ground. And likewise, if it rotates 336 degrees, the tip of the blade will be 61 meters above the ground. So there's our two answers.